Welcome back to my math teaching online today. In this video today, I will continue with the application of antiderivative in calculus to solve the word problems. So let me read the problem to you. Sorry. A pebble is tossed upward at 5 meters per second from a roof of a building 18 meter height. When will it hit the ground? Okay, so on the board, I have demonstrated the problem by the diagram. This is the building. There's a guy on the top of the building, toss a pebble from the roof of this building, and the height of the building from here to the ground is 80 meter height. So the question, and it say that the initial velocity when he tossed the pebble, it's not zero like we just dropped the object. So initial velocity here is different from the previous problem. The previous problem we're talking about, the object was dropped from the helicopter and initial velocity is zero. But in this question, it's different. It have initial velocity, and let aside the same, like upward is positive and downward is negative. So initial velocity is V0 equal positive 5 meters per second. So we know that. Now at the time, at zero, he hasn't taught the pebble yet. Now, on the diagram, I have shown upward arrow stand for the height of the building. What does that mean? It means that in this problem, we assign the height of pebble is 80 meters, positive 80 meters upward, because we consider when this guy tossed the pebble have been taught from a roof of building. So the building have a height of 80 meters. So it means the pebble was taught from that height. So the pebble have its height at 80 meters at the beginning. So this one like H0, right? And down here, let's say this is H final. And when the pebble going down to the ground, its height is 0. But at the beginning, when it was taught, it had its height of 80 meters and its upward direction. The gravity is the force of the earth pulling any object on the surface of the earth. So the gravitational force is the acceleration and represented by minus 9.8 meters per second square. This number is never changed, it's always like that. Sometimes people draw it up and get it like minus 10 meters per second. That's okay as well. But anyway, this is the acceleration, the gravitational force pulling the pebble down. Now, we notice that, what else do we notice? So we have V0 equal 5 meters per second square, H0 equal 80 meters, and acceleration is minus 9.8. So let's write down the acceleration. This value is always there. So A equal dv over dt, which is the rate of change of the velocity, right? And also the same like v prime t. So the velocity change respect to the time, v prime t. And this v prime t equal minus 9.8, never change, right? So now we're going to find what is the question asks us. When will it hit the ground? So the question asks us how long how long the peptone will go all the way from maximum level here down to the route. So they ask for time, and I put T here equal question mark. So the time here at the route, how long does it take for the peptone going down with the initial velocity of 5 meters per second. So let's write down our equation. So we have V grind T equal minus 9.8. So if we integrate this value, which is dV over dt, then what happened? If we integrate this value, we got back to the original VT. And this value for integration is minus 9.8 dt, and that equals velocity function, Vt, the velocity of the peptone respect to the time. So let's integrate that. And this process we call an antiderivative, which is minus 9.8 divided by 2 t squared. That is, everybody know about this, right? That's how we integrate it. We add 1 power in here, so power 1 for t. No, sorry. Actually, this is just minus 9.8 t when we integrate this value. We got minus 9.8 t plus c. Okay, so this equation is actually, let me write out the name of this equation so we're not confused. So the velocity equal minus 9.8 t plus c. Is there any way we can find out the c value in here? Let's try. So we know that our initial velocity V0 here is 5 meters per second. That given information. So I'm going to make this equal 5, right? 5, because that's our velocity at the beginning. And that is when the time equal 0. So we're going to substitute time equals 0 because that's the starting time when the peptone just left the hand, right? So at time V0, minus 9.8 times 0 plus C equal 5. So it turned out our C equal 5. Because everything here will become 0, it's gone, so C equal 5. So now write back to the equation, velocity equal minus 9.8 t plus 5. That's the velocity function. So if we integrate the velocity function, we get the position function. And that is the same like integrate of V of t will be equal integrate of minus 9.8 t plus 5 dt, and that will be equal h of t. So we integrate this velocity, we get back to the position function, h of t, which is like the displacement, right, function. So this will be equal, integrate this will be minus 9.8 t squared divided by 2, that's how we integrate, adding with 5t, add c. So now our function will be h of t equal minus 4.9 t squared, adding with 5t, and adding with c. So now our job is how to find what is a c when our initial position, initial velocity is 5 meters per second. At that position, what is the c? What is the position function supposed to be here, right? So now we're going to figure it out. How do we figure it out? Now, at the time t is 0, right? At the time t is 0, this peptide have a height of 80 meters, positive 80 meters, right? So we're going to substitute here h of 0 equal minus 4.9 times 0 square, follow the expression 5 times 0 plus c, and this height at the time 0, pipette have the height of 80 meters. So now calculate it, everything becomes 0, 0, so our c equal 80. So now we will write back the equation. H of t equal minus 4.9 t squared plus 5t, and c is 80. So write 80. So this is our position function. After we integrate and we use antiderivative method, mathematical technique in calculus to integrate the position function. Then we have a position function, which is the height function. And the height function now, we have it now, right? After our integration, we got this equation. So how do we find out the answer? The answer asks for when will it hit the ground. So it asks for t. And you know, this is the quadratic function, right? And to find the t, you have to know the equation. So what is the equation? We can set it up here. When the pipette hit the ground, its height equals 0. Its final height equals 0. So therefore, we can set up this equals 0, right? So at the time, at the time when its height, the pipette height is 0, we solve this equation, we get the t, and that is our answer. So let's solve it. And if I remember how to solve the quadratic equation, I guess my 12 students should remember this, right? So we have t equal, let's subtract minus b, which is minus 5, right? Minus 5. Okay, so t equals, minus 5, right? Adding and subtract b squared. B squared is 5, so 25. Minus 4 times a times t, and a times t is minus 4.9. A times c, times with 80. And all of this will divide it by 2a, which is this number times twice, so it back to become minus 9.8. Okay, so let's solve this equation and find out. So on my calculator here, I'm going to show you the way I do. I'm going to key in everything on the square root first, and I add back, subtract back to here, because that will be operated more easily, right? So we do the complicated first. So I'm going to key in the square root. Let me turn it on. So we're going to key in the square root, right? And I'm going to put in 25 minus 4 times minus 4.9 times with 80, close the bracket, and enter it and see what happened. Oh, yeah, I just squared. So now let's get the answer. Oh, something's wrong. Maybe I should put another bracket. What's wrong with this? Okay, let me try it again. 7 square root. 5 square is 25 minus 4.9 times with 80, close the bracket. It's one more. So we get 20.42. Now I'm going to use this number. I'm going to take away 5. So minus 5, enter. We got that. Now, so we get this number. So now the t will have two values, right? One is positive, one is negative. The positive will be this number, right? Divide by minus 9.8. This will be equal minus 1.57 second. But because it's a negative, so we reject, right? Because we don't have any time negative. So now we're going to focus on the positive time. Our positive time will base on the same number, which is 15.42 divided by 9.8. Actually, both of them negative. So when both of them negative, will turn out to be positive, right? When you divide. So I just use a positive divide right now. Get 1.57, exactly the same, but it's positive. So it takes 1.57 minute, second for the peptide formed from the building to the route. So that is our answer. And how easy it is, right? When we learn about mathematical methods and we use it with song, we just apply the formula and we just apply the concept idea. There's nothing difficult, except there is a little bit thinking when you have to think about it like a physics, right? So when you have to design, you have to think about, oh, this height is, we're gonna say it positive direction or negative direction. So that is the first thinking you have to think about this problem, right? Secondly, you will decide, is that the height of the peptide start from here? We're gonna make it 0, or we're gonna say that is 80-meter height. So that is a little bit thinking. It's different from the previous problem. We make the height is 0 at the beginning because the object was dropped, and we count the height as the negative direction. So we say right here, the height is 0, but let it go. So then we count the height from the route to here, then it drop, then from the route to here, it go from negative direction, how high it's supposed to be, right? Now, in this question, we're talking about the peptide was right here, and dry at the beginning, it has already count from, if we assign the positive direction, everything here is positive because the velocity was taught the peptide up as well, right? So it's positive 5 meters per second, and the high here, when the peptide sitting on the hand of the guy, that it have its highs of a positive from the route up to here, 80 meters. We assign the direction is positive, right? And of course, the direction of the acceleration is downward. So that is just require a little bit of thinking at the beginning. Rather than that, we just apply the antiderivative and so on for it. So I hope you enjoy my video, and I'm going to end this video right now. We'll see you in the next video. So thank you for watching, and bye for now.